Okay, thank you very much. I'm very happy to be here and to present our work on dynamic variant for effect handlers. Of course, this is joint work by Jonathan Brachthäuser, Philipp Schuster, and myself. And as you can see by these fancy badges, we also have an artifact available. So I invite you to check out the artifact and have a look at the examples and test the implementation. Okay, before going in deeper, I want to give you some context. So the context switch might be easier for you. I'm in the fortunate position that we already had a great talk about effect handlers, but I'm still going to give you a short summary. We are in the context of lexical effect handlers. We have multi-shot continuations, and with these tools we can model complex control flow, for example, asynchronous programming, non-determinism, probabilistic programming, and many more things. So the idea we are presenting in this talk are implemented in the effect language. We also have a website, you can see it here. I also invite you to check it out after the session. And given this context, let's look at an example. We have the following program. We have a handler for the flip operation. I'm going to get how this is defined in a second. We have a mutable global reference that initially just has the value hello. And we have an if statement. And in this if statement, we are executing the flip effect operation. And then we are going to mutate the reference and in one branch append the word hello, the word world to it. And in the other branch, we are going to append the word Singapore. And then in the end, in either cases, we're going to print out the result. So this is how you typically write the effect handler for the flip operation. You are resuming twice, so this might be perhaps a bit hard to get your head around. Once with true and once with false. So in the first resumption, we are executing the first branch, and in the second resumption, we are executing the second branch. Okay, so let's pause for a second and think about how we would expect this program to behave. Perhaps it's easier if we write another program for seeing how it should behave. If we are using stack local mutable variables, it should behave like here on the right side, because in effect, local mutable variables are backtracked by default. So in the first resumption, we are appending world to hello, and in the second resumption, the reference or the variable still contains only the string hello, but not world from the first resumption. So it's backtracked. So we are getting hello world and hello Singapore. But this is not what we are getting in the left example. What we are getting instead is hello world and hello world Singapore. So it's not backtracked. And this leads us to our problem definition. What we are trying to solve and what the problem is, we want to enable and allow backtracking or formalization of external resources. For example, as we have seen, global mutable state, or also maybe perhaps database connections or file handles. And we want to do so even in the presence of complex control flow given by algebraic effects or effect handlers with multi-shot continuations. And the solution we propose is a bit similar, if you squint your eyes a bit, to try finally, from other languages, like Python, for example. But we have two cases, because with effects, we can also resume, so we have to think about both directions. And the solution we propose is that we make the process of unwinding and rewinding the stack, so resuming and suspending a computation, observable. On suspend can observe when we are unwinding the stack, when we call an effect operation, and dually, on resume can observe it when we are rewinding the continuation back on the stack. And with this in mind, we can go back to the example and try to fix it. So now we are going to define the backtrack function. The backtrack function gets the global mutable reference and also the remainder of the program. In the body, we are going to use this new statement and the new clauses on suspend and on resume. And let's try to fill out the on suspend first. It's very simple if you just see it like this. We just get the current value of the reference and do nothing with it. But that's not true. We actually have access to the return value of the on suspend clause as a parameter in the on resume clause. So we are saving the current value of the reference when we are initially calling the flip operation. So when we call the flip operation, we have to traverse through this backtrack function. So the on suspend is run and we save the value hello, and upon each resume we are restoring this value again in the on resume clause. And with this we get the desired behavior. We get hello world and hello Singapore. Okay, this is the semantics session, so let's talk semantics. How does this work? It is helpful, I think, not to show the stepping relation, but instead be a bit more visual. So this is the stack. This is not a one-to-one representation of the program, but the important parts are here. We have the handler for flip. We have the suspend and on resume clauses. We have an empty handler. In this case, it's empty, but you can also have a handler here in the backtrack function, and perhaps also some other frames. Okay, so now imagine we are in the process of calling the flip operation. So that means we need to unwind the stack and find the corresponding handler. And because we are using lexical effects, we know exactly what handler we are looking for. So it's the label L1 or the prompt L1. So that means we have to unwind the stack until we reached the stack with number 2. Okay, so let's just pop the frames from the stack and push it onto the continuation. Okay, so now we have pushed all these frames, but now we have also pushed the on suspend and on resume frame. So now we need to pause what we are doing and execute the on suspend body. That means two things need to happen. We need, of course, to execute the program r.get, but also we need to remember somehow that we still need to continue with this unwinding process later on when this body is or has been executed. So we are pushing a new frame on the stack that is called unwind, fittingly, and this allows us to remember all the important information to later reconstruct what we were doing. And perhaps skipping some steps, eventually we'll just return hello after executing the on suspend body. And then we see that there is this unwind frame, which we want to return to, but this now serves as a reminder to continue this unwinding process we earlier started, but suspended briefly. And as I earlier said, we also need to save the value hello in the continuation so that we have access later in the on resume clause. So we are also saving it in the frame, and then we can resume with this original unwinding of the stack. And eventually we will find the correct handler, and then the handler will resume. So let's think about the other direction. How does it work? Interestingly, it just works the same. It's just symmetric. So imagine now we are resuming the computation. So we need to unwind the stack, rewind the continuation onto the stack, and then on this stack that then is computed, we need to return true. And again, now we have this finalization frame we need to put back on the stack. So we are using the same trick. We are pushing a new frame called rewind, and that also serves as a reminder to later continue this resumption process. And yeah, we are going to return just the unit value here, and then we see again the rewind frame, and notice we need to continue this resumption process. And then we can just continue doing so, pushing the frames back on the stack. And then eventually we will be back at the point where we started, and the program can resume. So much for this. We also have some standard theoretical results. We have progress, we have preservation, and also, of course, then also soundness. Perhaps a bit more exotic, we also have a theorem called resource safety. I think it's easiest to understand what it says by looking at an example. So what we did is we have some invariants that the user needs to uphold, namely that when having a resource, for example a file, the first thing the user should do is, in the suspend clause, is to close or finalize the file, and as last thing on resume, the user should reinitialize the file, in this case open it again. And if the user does this, then we have proven that all resources on the stack are actually initialized, so they are safe to be accessed, and all other resources are closed or finalized. So in summary, we have in our language, we have multi-shot continuations which require special care when adding dynamic finalization to the language. And for this, we have added 2 or 3 new clauses to the effect handlers, namely on suspend, on resume, and on return. And what I didn't show in this presentation, but what just arrives naturally, is that you can even call effect operations in on suspend and in on resume, and it still works. Okay, so now that you have seen the presentation, why would you even read the paper anymore? We still have some things to show. We have a type system for the language itself, for the calculus. We have a type system for the stack, for the continuation. And of course, we also have operational semantics. This might also be interesting for you to look at if you just are interested in how lexical effect handlers work operationally, even if you're not interested in the formalization itself, because this is very fine-grained and it might be informative to look at. And of course, we also have the proofs and the theorems. And here's the link to the paper. I invite you to look at it, and I'm happy to hear your questions. Thank you. Hi.
Hello. Very nice talk.
Thank you.
So I have a question on the example with the files.
Yes. Let me go back here.
So to what I understand, since you have multiple multi-shot continuations,
yes.
The suspend runs once, but the resume can run multiple times, right?
On suspend runs multiple times.
Yes. So
it's well bracketed. For every time you close it, you open it again on resume.
But if you have a handler such as flip, then
yes.
would the resume runs twice for every time suspend runs once?
No, suspend is also executed twice. Oh yeah, of course. But I'm happy to discuss this offline.
Okay.
Yeah.
Yeah.
Okay.
So let's take the speaker.